Coming up as our second keynote speakers for today, we have Matt Butcher and Rajat Jindal from Fermyon. Special mention to Matt that he has come from US, all the way from US. Thank you. And in this talk, Matt and Rajat will be introducing Spin, an open source tool for rapidly building serverless functions in WebAssembly. Thank you.
I'm so happy to be here today. Wow, this is fun. I'm Matt Butcher. Some of you may know me from my history in the Kubernetes ecosystem. We created Helm and the Illustrated Children's Guide to Kubernetes. But I'm not here to talk about either of those today. I'm here to talk about WebAssembly and the next wave of cloud computing. The slides are not here, so I will keep going. Well, so we landed in India about, it must have been a week ago today, and we've kind of made a journey from Bangalore to Hyderabad to Pune, and then to here, and then to Thane tomorrow. It's been a fantastic trip. For those of you who don't know what I'm doing these days, I'm the CEO of Fermyon Technologies. Radu, who's the CTO, is sitting in the second row over there, and Rajat, who's joining me on stage, is one of our engineers. And what we're going to do today is we're going to go through two things very quickly. I'm going to do a little bit of an introduction about WebAssembly and why we are so excited about it. And then Rajat is going to show you in action an application that was originally built on another technology and then ported over to WebAssembly. So here's how we'll start. Not all technologies end up doing the thing that they were originally invented to do. Java was originally built to run on small embedded devices. If you saw like the early material that was circulated when Java first came out, they were talking about putting it on scanner cards and rings and very small embedded devices. As we all know, Java's big foothold right now is on the extreme other side, right, in enterprises. The World Wide Web is another example of a technology that was built for one reason and kind of outgrew its original intent. The World Wide Web was originally invented to trade physics papers. I'm glad that it kind of evolved from there because we get a lot of value out of other things besides physics papers. And Ruby on Rails is another example. So Ruby, the programming language, was built to be a kind of better shell programming language for Unix. For 10 years, Ruby was kind of considered an obscure language, not a mainstream language at all. So for 10 years, a very small community worked on this project until suddenly something changed and Ruby was suddenly thrust into the spotlight. And that was the invention of Ruby on Rails, which was not a shell programming environment, but a big web application development environment. So WebAssembly is going to be a similar story. It started as a technology for the web browser, and it has since moved on to become sort of a general purpose technology. So what is WebAssembly? Well, the kind of boring answer is it's a binary format. But the more interesting answer is it is a specification for how you can run all different kinds of programs on the same kind of language virtual machine. So we can look at this two different ways. The first one is we can draw an analogy to the programming language world. If you think about the programming languages out there, some compile to native formats like C, Go, Rust. Others are scripting languages that are interpreted during runtime. WebAssembly kind of falls into the third category with Java and .NET, where you have a language virtual machine and you compile your code to a binary format that is platform agnostic, right? Can write it once, run it anywhere, right? And then it runs on top of a virtual machine. So Java has the JVM, .NET has the CLR, WebAssembly is the language virtual machine. But the cool thing about WebAssembly that's different from these other environments is that it was designed so that all these different languages could compile to the same runtime. Now originally the purpose was so that we could run other languages beside JavaScript in the web browser. But it has since then kind of evolved in different ways. But let's start just really quickly and talk about what it would mean to create a generic language runtime that runs in a web browser. There are some characteristics that you would want to have. The first and foremost is you would want to have a really good security model. So kind of the first rule of building an environment like this in the browser is the thing that is running in the browser should not be able to attack the host. In other words, we trust the browser to protect us from any kind of dastardly evil code that someone may try and inject into a website, right? So when WebAssembly was being developed, one of the key features was a strong security sandbox. Second kind of rule of web development is that you cannot target a specific operating system or a specific architecture and expect your web application to do well, right? It has to be cross-platform, has to be cross-architecture. In other words, you can't say this website only runs on a particular version of Windows and on an Intel processor, right? So any core technology that's going to be built for the web has to be built to run on different operating systems and different architectures. The third one is that we are all very, very impatient. We do not like to wait for websites to load. Consequently, any good web technology has to be able to start up very quickly and execute very quickly. And then the last one, and this was a design goal very specific to WebAssembly, was that the format itself had to be such that it could indeed run any kind of programming language, from a scripting language through that kind of interpreted binary language and on to the low-level compiled languages like Go and Rust and C. Now there's an interesting little catch to that last one. If you're going to support all of the languages, you have either one very, very big job or about 400 very, very small jobs. You either have to port all of the languages to WebAssembly, or you have to convince every single language community to support your standard. WebAssembly took that latter route and is working with many, many different programming language communities. Of the top 20 programming languages right now, about 17 of them can or will very soon be able to compile and run in WebAssembly. So I kind of set this up by saying, okay, you know, Java outgrew its original purpose, Ruby outgrew its original purpose, the web outgrew its original purpose, WebAssembly is outgrowing its purpose. What do I mean by that? Well, those 4 characteristics we just looked at, they turn out to be generalizable. That is, there are a lot of different environments where those particular features, security, speed of startup, cross-language, where those things can be useful. So for example, there are 4 major domains that I think of when I think of places we could do WebAssembly. The browser's the obvious one, right? When you have a small, compact binary format, though, that can run in all kinds of different environments, it's very useful for IoT. So for example, BBC, Amazon Prime, Disney Plus, they all use WebAssembly in the players that they have, right? So if you're streaming any of those, WebAssembly is a key technology there. Why? Well, because as BBC put it when they wrote about it, when you have 9,000 different devices, from streaming sticks to smart TVs to Apple TVs, you really don't want to write the same C code for all 9,000. So you write a small little shim for the hardware and you run everything else in WebAssembly. Another good example would be the plugin model. We all build applications that at some point have to sort of outgrow what they do, and so we want third-party developers to be able to add new features, and so we create plugins. And up until WebAssembly, most plugin models were based on the idea that you embed a scripting runtime in your platform, and then developers, you provide them an API and they come along and write programs only in the one scripting language that you support. WebAssembly changes that story a little bit and says, oh, you can, run it in any language, write it in any language you want, as long as it compiles to WebAssembly, and then you can run it in the platform. So I think that those 2 areas, IoT and plugins, you'll see a lot of interest in WebAssembly. But the one I'm really excited about is that last one there, cloud, right? So why is cloud such an interesting platform for WebAssembly? I come from Azure. I worked in Microsoft Azure for many years. Prior to that, I worked at another startup, and prior to that, I worked at Google, and prior to that, I worked at HP. I'm the HP Cloud Group. So I've been doing cloud for quite a while. Started with virtual machines, right? The big, heavyweight workhorse of the cloud. At HP, we were building HP Cloud, which was oriented around virtual machine technology. Along came containers. And with containers, we got a lighter weight version of what we had with virtual machines, right? You just take your application, package up a little wedge of the file system with it, just the stuff your application needs, and then instead of moving around a multi-gigabyte image, you're moving around a few 100 meg of data. So containers really kind of changed things. But still, it seemed like there might be a lighter weight class. So at Azure, we're looking at a number of different trends that are happening in the industry, and one of them is serverless computing. Now, serverless is great. Developers tell us all the time that they really love serverless, but serverless has some very unique runtime requirements. When you're running serverless, a request comes in, you want to handle the request as fast as possible, and then send out a response. Now, contrast that with the way we usually build microservices. When we usually build microservices, and these are the things we usually put in containers, the way we usually do them is we create a long-running process, a server process, that listens on a socket, and each time a request comes in, it delegates it to the right handler, which deals with that and then returns it back. But if you've written one of these things, you know you're always doing the same kind of stuff to start up. It's create the server, manage the TLS certificates, manage the process, handle interrupts, and you're doing all this boilerplate code, all of which you get to maintain for the lifetime of the product, right? You're writing all this boilerplate code just so that you can finally get to this moment where you're like, yeah, this is the thing I care about, right? The request comes in, I handle it, and I return the response. Serverless says, don't worry about any of that wrapping stuff. The platform itself will take care of running the server, managing the TLS, all of that. You just focus on writing the event handler. Request comes in, you do your thing, you send a response. Developers tell us over and over, oh, we love that model. This is the thing we heard over and over at Azure. But the runtime platform that we need for something like that is not going to be virtual machines, and it's not going to be containers. So the current like Lambda, Azure functions, Google Cloud functions, those are all based on either virtual machine or container technologies, most of them actually virtual machine technology. That's why they tend to be slow to start up. They take around 200 to 500 milliseconds in Lambda's case, which is actually fairly fast to start up. Why does it not? Why would I call 200 to 500 milliseconds slow? Well, does anybody know what the maximum amount of time Google will wait and the Google page speed ranking before it starts penalizing you for your performance? 100 milliseconds. And why 100 milliseconds? Because we are so impatient that our attention begins to drift at 100 milliseconds. And so if you're gonna write high-performance web-facing applications, you've got to be returning data to the user by around 100 milliseconds. If you have 200 to 500 milliseconds before the cold start finishes, you can't even start doing your part of your job until then, right? So you're already starting to lose users. Radu recently saw in an article he shared with me that for every 10 milliseconds of latency you introduce into the pipeline, you start to lose users. They actually leave your site. And this is in the research he showed was in the shopping cart world. And people abandoning their carts is like the last thing you want. So this level of performance is actually really important. Even while most people are not aware of it, they're losing attention that fast. So what we wanted to do was find a platform that could run serverless functions very, very quickly, and that's where we ended up with WebAssembly. We really leaned into the features of WebAssembly and said it's a secure runtime, that just like it can run in the browser securely, we could pick it up and put it in the cloud and run it there securely. We could get these astronomically fast startup speeds, where instead of getting 250 milliseconds of cold start time, we were down to sub 2 milliseconds, now sub 1 millisecond. So that means if it takes you, when you write your code, around 50 milliseconds to do your thing, which is normal, right? Then we can get a response to the user in 52 milliseconds, well before their attention starts to dwindle and they start looking at their phone to see what the last notification was. And so we're very excited about WebAssembly. We built Spin, which is an open source developer platform that's designed to get the user from blinking cursor to their first deployed serverless application in 2 minutes or less with just a handful of commands. We'll do a workshop on this later on this afternoon, so if you want to get a hands-on experience with it, you'll have an opportunity coming up. But I'm going to pass off now to Rajat, who's going to walk through an application that was developed with this kind of technology, or rather refactored to use this kind of technology.
Hey folks, morning. My name is Rajat. I work as a senior platform engineer at Fermyon. And some background about me, I actually started my open source journey in 2018 when I created the Good First Issue bot for myself as a medium to notify me whenever there is a new Good First Issue reported in any of the open source repository, because every time I would go to a repository to find a Good First Issue, it was already taken by amazing community members. I also happen to create and run the kubectl plugins release bot. So this is the bot which is used by almost all the kubectl plugins to do the releases automatically. I also run a translate thread bot on Twitter, which is used for translating the Twitter threads from different languages to English, just to bridge the gap. Again, these are all the stuff that I built for solving the problems I was running into, because I wanted to get involved with the community, and these were the issues I was running into, and then it happens to be the same issues that other people are also running into. I love serverless, as you can tell from the projects that I have done so far. I am currently exploring Rust and Wasm, and you can follow me on Twitter, and that's my GitHub handle there. So what is Good First Issue bot? So it's a bot that I created, like I mentioned, for myself, because I wanted to be the first one to be notified of a new Good First Issue bot, so that I can go and explore if I can work on that or not. So it has basically three parts there. One part is where a repository or a org in GitHub, they basically install this application on their repository, and then as soon as it is installed, whenever there is a new issue reported, it sends a webhook notification, and that's where the second part comes into the picture, the serverless function, which is listening for those webhook events, and based on some very basic criteria about the labels on the issue and stuff, it makes a decision that should I be posting this to Twitter or not. The first version was sending a DM to me, but now I have opened it up for, like, it should be posting in a public channel so that anyone can go and try and contribute to the Good First Issues. The third component here is the social media account. So I have a Twitter account there, Good First Issue, and a Blue Sky account that I recently enabled, so it will get the links of the Good First Issues reported there. So these are some of the amazing organizations which actually have enabled the Good First Issue bot on their repository. I'm really glad that I got on I don't know if he remembers or not, but I got on a call with Helm community once, few years back, and presented Good First Issue bot to them, and they were very gracious in enabling it on Helm, and then some Google, Adobe, Alex Alice from OpenFaz. These are some of the repositories which have enabled the Good First Issue bot on either the complete org or some specific repositories on them. So what really happens is when someone reports a Good First Issue on the repository, a tweet like this is sent. So any follower who is following the Good First Issue bot will get a notification about that. And what I say here is, like, a lot can happen over GitHub Issues, because that's how I started my open source journey. And I'm really glad that I'm able to work with Fermyon thanks to the contributions I made to the open source community. And this is where you can go and say, hey, I want to work on this issue. And maintainer would be like, yeah, sure, you can work on it. And if you need help, I can help you with that. So that's how you start your journey, right? So I started my journey like that. So in a nutshell, this is the architecture for this complete bot. So there is a GitHub which sends the webhook event, and I have the Good First Issue webhook, which is deployed currently on Fermyon Cloud, but it can be like it's using Spin and WebAssembly, so it can run anywhere Spin and WebAssembly can run. And then for credentials and caching, I'm using the inbuilt key value pair, which is provided by Fermyon Cloud. And the good thing about this is I don't have to deploy DB or key value pair database or anything by myself. Like, I don't have to manage any of that. That already comes for free with the Fermyon Cloud or Spin if you're using Spin, and then you can just hook it up with it without any credentials. You don't have to provide anything explicitly. Everything is taken care of by the framework implicitly. And then once the vetting of the issue event is done, it sends the tweet to the Twitter. And Blue Sky is still missing because I just enabled it like last week. So what were the challenges that I faced when I was trying to port this to Wasm? So one was where to store credentials. Before this bot was running on a Kubernetes cluster that I run on a public cloud. And I could use the Kubernetes secrets to store the credentials and then mount that secret on the Kubernetes port and read from there from a file. It was simple, but with how do I do that with Wasm? That was the first challenge. Second was how to do the caching. So again, it was a long running process in the Kubernetes cluster, so I could do in-memory caching, and caching was really needed because there will be multiple events that will be sent to the bot, whenever someone is reporting the issue, then he's adding the label. So it will be multiple. I don't want multiple events, and I don't want to post multiple links to Twitter or Blue Sky for that matter. So I needed some sort of caching to avoid the duplicate tweets. Some incompatibility, so we use TinyGo to compile the code. TinyGo is a different version of Golang, as in like it basically enables us to compile the code, the Golang code to WebAssembly, and there was some incompatibility we ran into, and one of them was one of the logging library that we were using. And another one was like Matt was mentioning, WebAssembly is a sandbox, so by default it does not allow you to make outbound HTTP calls. So how do I make those HTTP calls for tweeting or for sending the skeets to Blue Sky? How do I do that using WebAssembly? So it turns out that, like I mentioned earlier, Spin has an inbuilt key value pair which can be used for storing the credentials and doing the caching, so that we can do that. It's a serverless, so like the function is executed and it dies. There is no in-memory caching or there is no file system where we can store the credentials. So inbuilt key value pair came really handy there. For the incompatible dependencies, because it's a bleeding edge technology, so we do run into some issues sometimes. There are rough edges still that we are ironing out. And so we submitted the pull request to the logging library, and I'm really happy that it got merged last week. So that's how you make progress, and that's why I love open source. Making outbound HTTP calls against Spin provides a SDK that provides you the host functions, host components that can be used for enabling the capabilities in your WebAssembly module, and one of those capabilities was outbound HTTP calls that we were able to use here, and then it just worked. So those were some of the challenges that I had. And why I'm telling you that, because I'm telling you all this stuff from an end user perspective. Like I am not that much into WebAssembly, deep into there, right? But from an end user perspective, what were the challenges I faced to move my Golang application to WebAssembly? And there were not many challenges that I had. I could use the same SDK that I was using earlier. Like for Twitter, I was able to use the same SDK. For GitHub, I was able to use the same SDK. For Blue Sky, I was able to use the same SDK. So that was amazing. Just a very quick slide on the latency. So Matt mentioned about the cold start times, and these are the latencies which are reported by GitHub. So this is from the end user perspective, what type of latencies they see. I don't know if it is very clear, but most of the time the latencies that we are seeing here is 50 milliseconds, and that includes the webhook, sending the webhook, processing the event, in case if you need to post it to Twitter, and then send the response back, and all that takes about 50 milliseconds. That spike there is Blue Sky. I was trying to do the Blue Sky integration, and then Blue Sky APIs are a little slow, and we are working on, like the WebAssembly team is working on making sure we can do asynchronous HTTP request as well. So once that is there, those spikes will die down as well. I think that's all I had to cover. If you have any questions, maybe we can cover that later. Thank you.
Yeah, have them come by the booth. If you've got questions, feel free to stop by our booth, and we're happy to discuss.
Thank you.
Thank you.
So that was a very informative session by Matt and Rajat. I hope audience must have also got some great insights from it.